A biogas is a clean cooking gas made when bacteria break down waste without oxygen in anaerobic digestion. This project uses cabbage waste and cow manure as their household. In Papua New Guinea, many villages have no electricity and they use firewood, which cut trees, make smoke, harm their health. Biogas can give people free cooking gas, reduce ravages, and save our forest. Our country policy also supports small biogas systems. So in this project, a 20-liter plastic digester was used to test if cabbage waste and cow manure can really produce biogas. So there are three objectives to be achieved in this project. Okay, number one, to prepare and construct a small-scale polymer for biogas testing. Number two, to determine biogas production potential of cabbage waste co-digested with cow manure. Number three, to help students understand and improvise on creating their own biogas in the future. Alternative hypothesis says big change in biogas over 3 weeks with more active in 2 to 3 weeks as waste breakdown. Null hypothesis, no big change in biogas sign. Before the progress of the project to begin, first the project was discussed and designed with a quotation list of materials to be purchased, and materials used are tape, collector tube, joints, 20-liter container, silicone, drill, PVC polypipe, a wheelbarrow tube, thread tape, Benson banner, cow manure, cabbage waste. Yes, the group members contributed each given amount for the project to carry out. According to the group budget, the group members traveled to town to the hardware store to purchase the materials listed in a quotation. Once inside, they began selecting and buying the materials as needed. The total cost of these materials was 300 kina. A polypipe was measured and cut using a saw, marked around the lid of the 20-liter container and drilled. Then a gas outlet was joined and a PVC polypipe was connected where it drilled. Silicone was applied around the lid where both PVC polypipe and gas outlet tube were connected and tightened with a thread tape. So the lid was closed and additionally silicone was applied around the connection to ensure there were no holes or gaps. The lid was carefully placed on a 20-liter container and pressed down firmly. The outlet system was drilled and connected and the tape was attached to the outlet. Silicone was applied to hold firmly in seal any gap or any holes. A Benson panel was connected to the gas outlet tube and the tube was attached. A digester was loaded with 50% water, which is 10 liter, 20% airspace, which is 4 liter, and 30% substrate is broken down to 6 liter in total. The first 2 liters for cow manure, another 4 liters cabbage waste in ratio of 1:2. Substrate were approximated by mass of 2 kg cow manure, cabbage waste 4 kg using water density as estimated. Feeding and mixing performed carefully to avoid backflow in inlet 10 liters of water, which is 50%, into a bucket prepared for mixing substrate. Then prepared a cabbage waste and cow manure are 2 feedstock prepared earlier in pre-treatment process for decompose, which break down complex organic, increase surface area, and reduce size particles to enhance biogas production. Mixing the pre-treatment feedstocks with water create a slurry which provide optimal moisture for microbes, help distribute it evenly, facilitate easy pump into a digester. After everything was finished, finally feed or mixed was carefully added through the feeding PVC polypipe. This undergo anaerobic digestion. Within a digester, microorganisms break down organic matter in the absence of oxygen, producing biogas, mainly methane and carbon dioxide. It was left for 3 weeks. Over 3 weeks, hydrolysis occur, break down complex organisms into simpler compounds. Acidogenesis occur, which convert simpler compounds into volatile fatty acids. And next, methanogenesis occur, which produce methane and carbon dioxide. Okay, now let's go to our results. In week 1, the biogas digesters showed low activity with temperature 34 to 38 degrees Celsius, no smells at first but after late, occasionally tube expansion and no gas, sound or flame in week 1. So by week 2, the smell were present every day. The tube expand once with biogas sound on Monday, but still no flame indicate increased decomposition. In week 3, smell continuously daily with temperature from 29 to 38 degrees Celsius, but the tube mostly contract and there were no sound of a gas or flame. In the discussion, it indicates that the low production in week 1 and higher activity in week 2 to 3, though methane gas was not combustible, ignitable, likely due to leakage or the low yield. So the hypothesis stands in introduction part. We failed to reject the null hypothesis and reject alternative hypothesis because ANOVA test sums daily indicate yield a p-value of 0.284, which is greater than the 0.05 significance level, indicate no statistically significant difference in biogas indicators across 3 weeks. Therefore, null hypothesis accepted indicate no significant changes in biogas over 3 weeks. To conclude, this study demonstrates that a small-scale 20-liter polymer digester using cabbage waste and cow manure can produce biogas. However, lack of consistency ignitable methane highlights issues like gas leakage and uncontrolled pH and temperature affect the production of biogas. So it can be recommended that for future experiment, implement improved gas tighten connection, daily pH and temperature monitoring, and replicate trials to accurately quantify biogas yield.